Question 1 from the 2024 National 5 Physics Examination from the SQA. Which row in the table classifies speed, weight and energy correctly? Well, we know that speed has got to be a scalar quantity. We mark that there. Weight is a force basically, so it's going to be a vector, because all forces are vectors, so we've got a vector for weight. And finally, energy is a scalar. All energy is a scalar. So looking for scalar, vector and scalar, vector and scalar, the answer is E. Question 2 from Section 1 of the 2024 National 5 Physics Exam from the SQA. A student uses the apparatus shown to determine the average speed and instantaneous speed of a trolley as it travels down a slope. You can see the diagram there. The trolley is released at X and travels down the slope. The distance between X and the light gates at Y is D, and the time taken for the trolley to reach the light gate is T1. The length of the card on the trolley is L, and the time taken for the car to pass through the light gate is T2. Which row in the table shows the measurements required to determine the average speed of the trolley between X and Y and the instantaneous speed of the trolley at Y? Well, the average speed of the trolley is given by the following. It's going to be the distance gone divided by the time taken. And if you look close, the distance gone is D, so we'll put down D there. And the time taken to go from X to Y is measured on the stopwatch, and that's got to be T1. So we've got the average speed is D divided by T1. If we want to find the instantaneous speed at position Y, then we have to rely on an electronic timer, so it's obviously got to be T2. And we also know that we've got to measure the length of the card, because it's the card that passes through the light gate, which will in fact give us a time electronic timer. So the instantaneous speed, as best it can be at position Y, is the length of the card, L, divided by the time it takes to go through the electronic timer, and that is T2. So we're looking for the following. We're looking for the average speed to be D divided by T. So it's going to be this one here, D divided by T1. So it could be this one, or it could be D divided by T, or it could be this one down here. But the instantaneous speed is L divided by T2, and that's this one here. So that's the two that match up. So for question 2, the answer is B. Question 3 from Section 1 of the National 5 Examination. A rocket is taking off from the surface of the Earth. The rocket engines exert a force on the exhaust gases. So which of the following is the reaction to this force? So you have the picture here. We know we're going to have a Newton pair. We're going to have this force here, which is the force which the engine pushes the gases out, and therefore the opposite reaction force must be this one here, the force which the gases push back on the rocket engine. So we're looking for the force of the exhaust gases on the rocket engine. So that'll be that answer there, answer E. So as the recap, if the rocket is taking off from the surface of the Earth, the rocket engines exert a force on exhaust gases. So we're looking for the exhaust gases exerting a force on the rocket engine. It's the Newton pair, answer E. Question 3 from Section 1 of the National 5 exam. A motor raises a mass of 2,400 kilograms vertically through a height of 5 metres in 2 minutes. And we're asked to calculate the minimum power rating of the motor to raise the mass. Well, we have to do work on the mass, and that's raised up 5 metres. And when it's raised up 5 metres, it's going to gain potential energy of the value EP. That's going to equal to mgh. That's going to be the potential energy gained by the block. Now we know the mass of the block. The mass of the block is going to be 2,400, so 2,400 kilograms for the mass of the block. Therefore, we're lifting 2,400 kilograms up against gravity. We're giving it potential energy, and that potential energy has at that point is going to be 2,400 kilograms times 9.8 multiplied by the height it was lifted up, which is 5 meters. So we do that with a calculator, we get 117600 joules. So we've given that block 117600 joules. Now we've done that in a certain time, so we know that the power is equal to the energy transferred divided by the time taken to do it. And the energy transfer is 117600 joules. And we did that in a time of 2 minutes, which we have to write down in seconds. 2 times 60, and therefore we can't work it out with a calculator. We get 117600 divided by 2 times 60, and we get 980 joules per second, which turns out to be a watt. So we're looking for the answer B for question 3.